Hello everybody and my beloved friends, welcome to Cam's Engineering. This is part 2 for how to make a powerful subassembly from Autodesk Subassembly Composer. In previous video we had seen how to make lane layers. Different conditions for our shoulder slope by using if function. I think you don't like it because I have got only 3 subscribers. Today I will continue from last point. Let's start. Now we can continue making our fill and cut condition, but first we will create our existing ground here in target parameter. I call it EG, its type is surface. I will give -3 for preview value because I want to start first the fill section. I will give existing surface for display name. Okay, as you have seen it, my EG surface has shown in the preview. Next, insert an auxiliary point. Its type is delta x on slope. It starts from point 11. We will select surface target EG and draw a link. After this we will decide our condition, either it is fill or cut. But first we have to give our input-output parameters for our fill and cut conditions only. Let's see some highlights. These are side ratios depending on height of fill or cut and also the material. For example, for earth or soil material case, if height of fill or cut is between 0 and 1, our fill side slope and our cut back slope is the same, that is 3:1. I think you know it, and also varies as per your specification and country. Please use your number here. For our purpose, we will use the first case, that is soil or earth material. But we can change this ratio numbers in Civil 3D. Let's go to our composer. Now we will start inserting our inputs. The first one is FFS. It is not double, but it is slope. Our default value is 3:1, as we have seen it in the previous table in soil case. Its display name in Civil 3D is flat fill slope. The second one is MFS. It is not double, but it is slope. Our default value is 2:1, as we have seen it in the previous table in soil case. Its display name in Civil 3D is medium fill slope. The third one is SFS. It is not double, but it is slope. Our default value is 1.5:1, as we have seen it in the previous table in soil case. Its display name in Civil 3D is steep fill slope. Let's start our fill cases. We will insert the cut parameters later, by the way, to make it clear. These ratio numbers are visible in Civil 3D, and simply by changing these numbers you can use this powerful subassembly for all material cases. Let's go. Now we will decide if it is fill or cut. Insert a decision. Our condition is P12 minus a P to greater than or equal to 0. That means our hinge is higher than existing grout. Sorry, it is y value. I must write .y. Now insert two charts for our two conditions. The first one is, if the condition is true, it will be fill, and we will write FILL. The other case, that is, if the condition is false, it will be cut, and we will write CUT. By the way, you can use hinge number other than 0. Okay, now let's start with fill condition. Open our fill chart. Now we will make our three fill slope conditions depending on fill het. Insert the first auxiliary point. It is slope to surface. It starts from point 11. Its slope is negative FFS, that is our flat fill slope. As we have seen it from the table, our fill height is between 0 and 1 meter. Draw a link. Insert the second auxiliary point. It is slope to surface. It starts from point 11, but its slope is negative MFS, that is our medium fill slope. As we have seen it from the table, our fill height is between 1 and 2 meter. Its surface is EG, and draw a link. Insert the third auxiliary point. It is slope to surface. It starts from point 11. Its slope is negative SFS, that is our steep fill slope. As we have seen it from the table, our fill height is greater than 2 meter. Its surface is EG, and draw a link. Then we will define our final fill slope. Define variable. I gave its name FS. It is double. You can give its default value negative FFS. Now we will set our fill slope value. Set variable value. Its name is FS. Its value is simple, that is the previous table or your country standard, but please take care for if function. Or please insert the written value from screen. Its value is. If open 3 brackets, a P3 dot is valid without space, close 1 bracket, and open 1 bracket P12 dot, y minus a P3 dot, y less than or equal to 1 close to brackets, comma, negative FFS, comma, that is flat fill slope. Copy all this and paste it using Ctrl+C and V. Change AP3 to AP4. Again, change flat fill slope to medium. The condition also changed to 2. Now enter negative SFS and close into brackets. That means otherwise use steep fill slope. What is a problem here? Okay, it must be closed into brackets. Now we will define widening. Let's see the conditions. If our fill height is less than 3 meter, 0 widening. If our fill height is between 3 meter and 6 meter, we will add 30 centimeters widening. If our fill height is between 6 meter and 9 meter, we will add 60 centimeters widening. If our fill height is greater 6 than 9 meter, we will add 90 centimeters widening, but again you can use your condition. Let's go to our composer. Define variable. Its name is WD. You can use any name as you want. Its type is double. I will give the default value 0, but you can give any number here. And now we will set our widening variable. Change MD to WD first. Now our name is WD. Its value is. If open to brackets P11 dot, y minus a P5 dot, y close 1 bracket less than or equal to 3, 0, if open to brackets P11 dot, y minus a P5 dot, y close 1 bracket less than or equal to 6, 0.3, if open to brackets P11 dot, y minus a P5 dot, y close 1 bracket less than or equal to 9, 0.6, 0.9, close 3 brackets. This if function is nothing but the previous table of high fill widening. Please insert correctly or see the screen. Okay, after setting my widening value, I will draw it. Just insert a point, its slope delta x. It starts from point 11. Its slope is L14.slope, that means our shoulder slope. Its delta x will be our new WD, that is widening. Draw a link. Okay, now we can check our widening by changing our existing surface value. As you have seen it, the value is -30 widening. Change it to -5, it will add 30 centimeters widening. Change it to -8, it will add 60 centimeters widening. Change it to -10, it will add 90 centimeters widening. Sorry, it is not negative, it is simply our shoulder slope. Yes, it's corrected. Now we will start drawing our shoulder layers, but first we will insert a flowchart. For the beauty of our chart, insert a flowchart and open it. Insert a point ... its slope to surface. It starts from point 12. Our last point, its surface target is e.g. existing ground surface. Draw a link. Now we can draw our shoulder layers. First, we will locate all points for our four layers, and then we will link each other and finally shape. But first, we will insert our shoulder layers thickness in input-output parameter. The first one, I call it SHT2. Its type is double. Its default value is 0.1 meter. You can give any number. Its display name is shoulder 1 thickness. The second, I call it SHT2. Its type is double. Its default value is 0.1 meter. You can give any number. Its display name is shoulder to thickness. The third, I call it SHT3. Its type is double. Its default value is 0.2 meter. You can give any number. Its display name is shoulder 3 thickness. The fourth, I call it SHT4. Its type is double. Its default value is 0.3 meter. You can give any number. Its display name is shoulder for thickness. Let's start. First, insert 4 points for inside shoulder. Insert a point ... It is delta x delta y. It starts from point 2. Its delta y is negative SHT1. Check the link is right. Do the other 3 points as per the video. Again, we will locate the other side points using intersection point. This method uses to locate a point between 2 points or between a point and a link or between 2 links. For now, we will find a point between a point and a link. Insert intersection point ... Its type is link point slope. The link is L16. IT is our last link. The point is point 14. The slope will be L14. Slope. It must be similar with top shoulder link slope. you see our point is located. Do the other 3 points as per the video. We locate all shoulder points, therefore our next step will be make links between points. Make links between one point and another point. Insert the first link. It starts from point 14. Its end point is point 18. Insert the second link. It starts from point 15. Its end point is point 19. Insert the third link. It starts from point 16. Its end point is point 20. Insert the bottom link. It starts from point 17. Its end point is point 21. To see our points clearly, we will give a widening. Change 3 to a number greater than 3 to show widening. Yes, it is clear now. We can draw other links for opposite sides. Insert link. It starts from point 12. Its end point is point 18. Insert link, it starts from point 18. Its end point is point 19. Insert link, it starts from point 19. Its end point is point 20. Insert link, it starts from point 20. Its end point is point 21. Finished, now we will make our shoulder shape. Insert shape for all layers of our shoulder as per the video. As we talked before in previous video, we will give codes after finishing this power subassembly. Okay, my friends, at this stage we have finished the lane part. The shoulder part, our fill condition, our high fill widening. Let's check if it works or not by changing the parameters. First, let's check if it works for left side. Yes, it works. Now let's check our fill conditions. By the way, these parameters are visible, and also we can change all in Civil 3D. Let's see first by changing the fill height. Please see the video. Again, let's check the widening. Please see the video. Okay, it is best. In next video, we will see how to make different types of ditches. Cut conditions depending on material type of excavation and excavation depth plus. How to make benches. Thank you for listening. Since it is new channel, please like, share, comment, and subscribe. Thank you very much.